Hi everyone, today we're going to be looking at the Arduino Opta PLC IDE ladder diagram first program. The Arduino Opta IoT PLC allows you to conveniently program it using the Arduino PLC IDE in ladder diagram format. This is the most common industrial PLC language, a simple and intuitive method. Additionally, you can program it with any of the 5 official languages specified in the IEC standard and using sketches written in C++. This article will solely concentrate on programming the Opta PLC using ladder logic widely used in industrial automation and control applications. With ladder logic, you can easily design and implement logical operations by creating ladder diagrams that resemble the rungs of a ladder, making it very effective and efficient programming technique. Let's get started building the PLC ladder diagram. Detailed information contained in this video can be found at accautomation.ca. A link has been put in the description below. If you have not watched the other videos yet, there will be links in the description below that will start you at video 1. There will be links to the rest of the videos in the series as well. Start a new project. Open the Arduino PLC Integrated Development Environment or IDE software on your computer system. Start a new project by selecting New Project on the main software screen. You can also select New Project from the main menu, File. The third method is to select the icon for new projects. The New Project window will now be displayed. Enter the name of the project in the dialog box. This will be the name of the program stored on your drive. We will leave the default directory as it is. Ensure that the Opta 1.0 PLC is selected for the target. Select OK. This will now create and save your program file for the Opta PLC. Mapping physical I/O in the Opta PLC. The Opta PLC has physical inputs and outputs that we will need to map before we can use them in our project. In the Workspace window, select Resource tab at the bottom. Under Local I/O Mapping, you will see all the physical inputs and outputs on this controller. Select Programmable Inputs. The programmable input mapping will be displayed. We can assign a variable to each of the inputs that we intend to use in our ladder program. Under I/O type, we can select Digital, Default, or Analog. The analog resolution can be selected for the inputs. Select Relay Outputs, which display the relay output mapping. We can once again assign a variable to the relays that we will use in our ladder logic program. Select LED Outputs, which displays the LED output mapping. These are the status lights on the Opta PLC unit. We will make these represent the relays in our program. Select a variable name to the 3 LED outputs that we will use. The Opta PLC also has a front LED that can be different colors. We will assign the green output to indicate that the PLC is working. Select the button input to display the relay output mapping. We can assign a variable name to the user button input. Now that all the mapping is complete, we can save the program using the icon on the main page. We can also save the program by using the main menu, File, Save Program. Tasks in the Opta PLC. To access the tasks in your project, navigate to the Project tab and locate the task folder. You will see the list of I/O that we just mapped for this project. Expand the folder by clicking on the plus sign next to it. The tasks are categorized into Fast, Slow, Background, and INIT, or Initialize. To configure the task, right-click on any of the 4 task folders and select Task Configuration. Your programs will be executed within the designated task folders. The Fast task folder will execute your program cyclically every 10 milliseconds or 100 times per second. This can be changed by changing the set period to Yes. You will then be able to enter a value in the period column in milliseconds. The majority of programs that will be placed in this folder. Slow and background task folders can also be scanned cyclically. They are both set at a fixed period of 100 and 500 milliseconds. That's 10 times per second or 2 times per second. These tasks are ideal for functions like math, equations, etc. The INIT or initialize task folder is used to set variables or conditions in the PLC after it first powers up. It will run for a single scan. Select OK to close the task configuration window. Starting a new ladder logic program. To start a new program, from the main menu, select Projects, New Object, New Program. You can also do this by right-clicking on the project name, select New Program under the Add heading. The new program window will be displayed. In our example, we will use ladder logic or LD. Select LD. Name the new program ladder and assign it to the Fast Task folder. Select OK. Our new ladder program will be displayed in the work area. It will contain a single rung with an input and an output condition. This program also appears in the Fast Task folder and under the project as a ladder diagram symbol. The ladder diagram bar icons can be displayed or hidden by using the main menu, View, Toolbars, LD bar. As you will discover, there are multiple ways to move around and enter your program. Right-click on the rung number will bring up a menu to add, delete, copy, or document the rung. Selecting the contact and right-clicking will allow you to cut, copy, delete, change, or add additional contacts. Selecting the output contact and right-clicking will allow you to cut, copy, delete, add, or view the properties of the output. You will notice that as you are selecting the elements on your ladder rung, the LD toolbar is also actively displaying the options that are available. As you highlight over the toolbar icons, it will display a quick key sequence for that item. Save your Opta PLC program. Programming our ladder logic. Double-clicking on the input contact in rung 1 will display the Properties window. Select Delete. Double-clicking on the output coil in the rung, select the 3 dots to the right of the name. This will call up your object browser window. Select the LED Run for our output coil. This will be used to indicate that our program is running. Select OK. Right-click on the rung and add a new network after this rung. A new rung will be displayed as rung 2. Double-click on the input contact, select the 3 dots to the right of the name. This will call up the object browser window. Assign the input button tag. Right-clicking on this contact, select New Parallel Contact. This will add a contact under the initial one. Double-click on this parallel contact and assign it as input 1. Double-click on the output and assign it as LED output 1. Click right on the output and select coil. A parallel output coil will be displayed. Call this coil output 1. Right-click on the rung and select Copy Network. We could also use Ctrl+C after we selected the rung. Select the rung again and right-click, select Paste Network, Ctrl+V. This will add rung 3. Change the first input and output to the second. Copy and paste again for rung 4. Change the input and output to 3. If you forget to include an input or output, then go back to mappings and assign the variable. This must be done to include the physical I/O in the program. Select the compile icon on the main menu. If there is an error, then compiling will show this so we may correct. Download the ladder program to the Opta PLC. Select Setup Communication from the main menu online. In the Device Link Manager window, select Modbus TCP and then select Activate. Select Properties. We can now enter the IP address that we established last time in the following post, programming the Arduino Opta PLC Ethernet port. Our communication method to the Opta PLC is now set. Select the Connect button. You will see that our computer is connected to the Opta PLC controller. Select the download icon on the main menu. If we didn't compile the project first, the PLC IDE would have prompted us before downloading. Select Yes. The output window will display the status of the download operation. When this is finished, the bottom right side of the software will show you that the PLC IDE and controller programs are the same. Monitoring the ladder logic and variables. Select the Live Debug Mode icon on the main menu. This will highlight the inputs and outputs as the program operates. The visualization is a good way to ensure that your program is working correctly. Select the Watch icon on the main menu. This will display the Watch window. We can enter and select the variables or tags that we would like to monitor. If you enjoyed this video, please hit the like button below. If you have any questions about the video, please leave a comment below and I'll do my best to answer it. If you want more information about us or you want our free ebooks on numbering systems or robust data logging, please click on the link in the description below to get it. A new video is put every Monday, so make sure you hit the subscribe button to get more videos like this in the future. Remember to click the bell beside your subscription to actually receive those notifications. Thanks so much for watching. I'll see you next time. Stay safe.